What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about wireless technologies such as the 802.11 standards, cellular technologies, frequencies, channel bandwidth, channel bonding, MIMO and MU-MIMO, which I'll explain later on, unidirectional and omnidirectional antennas, and wireless site surveys. Let's talk about the 802.11 standard. So the first one we have is 802.11a, and it has a maximum speed of 54 megabits per second using the 5 gigahertz frequency band with a maximum indoor range of 35 meters. Then we have 802.11b that has a maximum speed of 11 megabits per second operating in the 2.4 gigahertz frequency band with a maximum indoor range of 35 meters. Then we have the 802.11g that has a maximum speed of 54 megabits per second operating in the 2.4 gigahertz frequency band with a maximum indoor range of 45 meters, and it is backwards compatible with the 802.11b standard. Then we have the 802.11n standard. This has a maximum speed of 150 megabits per second when using a single 20 megahertz channel, or it can run up to 300 megabits per second with channel bonding or 40 megahertz channels. It operates in the 2.4 gigahertz frequency by default, but it can also support 5 gigahertz frequencies as well. 802.11n has a maximum indoor range of 70 meters. It supports MIMO, MIMO, or multiple input, multiple output antennas to improve performance and range, although not all devices include multiple antennas. And then we have the 802.11ac standard. This uses only the 5 gigahertz band and supports up to 80 megahertz wide channels compared to 20 megahertz for 802.11b and G and 40 megahertz for 802.11n using channel bonding. This also supports multi-user MIMO or multiple input, multiple output, and the speeds of the 802.11ac is up to 433 megabits per stream when 80 megahertz wide channels are used. Let's talk about some cellular technology. So the first one we're going to talk about is GSM. That stands for Global System for Mobile Communications. The GSM, this is a standard developed by the European Telecommunication Standards Institute to describe the protocols for second generation digital cellular networks used by mobile devices such as mobile phones and tablets. Its main task was to develop a single consistent network for all of Europe and come up with a better and more efficient technical solution for wireless communication. The GSM standard operates on 3 different carrier frequencies. The first one is the 900 megahertz band, which was used by the original GSM system. Then you have the 1800 megahertz band, which was added to support the swelling number of subscribers, and the 1900 megahertz frequency, which is used mainly in the US. And one of the main advantages of the GSM standard is the ability to roam and switch carriers by using individual mobile units if partner units are located in their destination. Next, we have TDMA, or Time Division Multiple Access. So TDMA, this is a channel access method for shared medium networks. It allows several users to share the same frequency channel by dividing the signal into different time slots. The users transmit in rapid succession, one after the other, each using its own time slot. This allows multiple stations to share the same transmission media, such as a radio frequency channel, while using only a part of its channel capacity. TDMA is used in most 2G cellular systems, while 3G systems are based on what is called CDMA, or Code Division Multiple Access. And speaking of CDMA, that stands for Code Division Multiple Access, and this is a digital cellular network standard that utilizes spread spectrum technology. This technology does not constrict bandwidths, digital signals, or frequencies, but spreads it over a fully available spectrum or across multiple channels via division. Thus, there is improved voice and data communication capabilities and more secure and private lines. Essentially, CDMA offers more airspace capacity than TDMA based on the GSM standard. Furthermore, CDMA, it uses less power. The CDMA digital standard, this is a leading communications network standard in North America and parts of Asia. Next, let's talk about frequencies. So your wireless router uses radio frequencies to transmit internet to your Wi-Fi connected devices like smartphones, laptops, tablets, etc. The differences between 2.4 gigahertz and 5 gigahertz frequencies comes down to two factors: bandwidth or speed and its range. A 2.4 gigahertz connection travels farther at lower speeds, while 5 gigahertz frequencies provide faster speeds at a shorter range. Whether you choose 2.4 gigahertz or 5 gigahertz will depend on where and how you use your Wi-Fi connection. A lot of electronic devices and appliances, they use the 2.4 gigahertz frequency, including microwave ovens, baby monitors, and garage door openers. If you have many of these in your home, or you live in an apartment or a condo surrounded by other people that use the 2.4 gigahertz frequency band, you are likely to experience congestion on the network, which can potentially damage the speed and signal quality that you are trying to get access to. So now let's talk about the 2.4 gigahertz frequency real quick. So some of the pros associated with 2.4 gigahertz are as follows. It has a larger coverage area and it is better at penetrating solid objects. Some of the cons: it has a lower data rate, is more prone to interference, and usually you'll find a lot of devices that use this frequency. It has a maximum connection speed of approximately 150 megabits per second, and it has a maximum signal range from the router of approximately 410 feet. Also, you'll notice with the 2.4 gigahertz frequency, it has a total of 11 channels, with 3 of the channels that are not overlapping. That'll be channels 1, 6, and 11. So if you are operating on the 2.4 gigahertz frequency with your wireless router and you want the best connection possible, I highly advise you to set your channels to either channels 1, 6, or 11. Those are the only 3 channels that do not overlap with each other, which will drastically minimize your chances of dealing with interference. Let's talk about 5 gigahertz. So some of the pros associated with 5 gigahertz are: it has a higher data rate, it is less prone to interference, and usually there are fewer devices that use this frequency. Some of the cons are: it has a smaller coverage area and it is worse at penetrating solid objects. Its maximum connection speed is approximately 1 gigabit per second, and it has a maximum signal range from the router of approximately 410 feet when the signal is amplified. Let's talk about channel bandwidth. So bandwidth, this is a broad term defined as the bit rate measure of the transmission capacity over a network communication system. Bandwidth is also described as the carrying capacity of a channel or the data transfer speed of that channel. However, broadly defined, bandwidth is the capacity of a network, and bandwidth, this exists in physical or wireless communication networks. Let's talk about channel bonding, which is also known as Ethernet bonding or NIC bonding, network interface card bonding. And this is when a cable modem combines multiple channels to increase the amount of traffic that it can comfortably support. Channel bonding is a practice commonly used in 802.11 implementations in which 2 adjacent channels within a given frequency band are combined to increase throughput between 2 or more wireless devices. Let's talk about MIMO, or multiple input and multiple output. So MIMO, this is a method for multiplying the capacity of a radio link when using multiple transmission and receiving antennas to exploit multipath propagation. MIMO has become an essential element of wireless communication standards such as 802.11n and 802.11ac. Some smartphones and tablets simply use the term MIMO if they support 2 or more 802.11n and AC streams, and MIMO devices are available in the following configurations. You have a 1x1 where you have 1 transmit and 1 receive antenna. You have a 2x2 where you have 2 transmit and 2 receive antennas. You have a 2x3 configuration where you have 2 transmit and 3 receive antennas. Then you got 3x2, you have 3 transmit and 2 receive antennas. And then you got a 3x3, we have 3 transmit and 3 receive antennas. Now, the number of transmit antennas typically correspond to the number of data streams, also known as spatial streams, that the device can support. So in the case of a router that supports both 2.4 gigahertz and 5 gigahertz signals, the specifications include this information for each band. Devices that have different numbers of receiving antennas and sending antennas may be identified by the number of data streams it can send and receive. So for example, a device with a 2x3 antenna configuration can also be identified as having a 2x3:2 configuration configuration, and that would stand for it has 2 send antennas, 3 receive antennas, and a send and receive support for 2 data streams. Multi-user, multiple input and multiple output are multi-user MIMO. So multi-user MIMO, this allows a Wi-Fi router to communicate with multiple devices simultaneously. This decreases the time each device has to wait for a signal and dramatically speeds up your network, considering that the average household has upwards of 8 devices battling for bandwidth simultaneously. Multi-user MIMO will increasingly improve a household's Wi-Fi experience, especially when it comes to streaming and gaming. Next, let's talk about unidirectional and omnidirectional antennas. So unidirectional antennas focus radio frequency energy in 1 or 2 directions, which lowers the beam width and overall area covered, but increases the strength of the signal and distance covered in that direction. An omnidirectional antenna is able to radiate or receive equally well in all directions. From the locus, the signal is emitted in the 360-degree plane to cover a certain area. Because the signal is not focused, the distance that it reaches is generally small relative to that of a unidirectional antenna, and typical applications of these antennas include hotspots for Wi-Fi, either indoors or outdoors, where multipath environments exist. And let's talk about a wireless site survey. So a wireless site survey, this is the process of planning and designing wireless networks to provide a wireless solution that will deliver the required wireless coverage, data rates, network capacity, roaming capability, and quality of service. The survey usually involves a site visit to test for radio frequency interference and to identify optimum installation locations for access points. This requires analysis of building floor plans, inspection of the facility, and use of site survey tools. Also, feedback from IT managers and end users of the wireless network are also important in determining the design parameters for the wireless network. All right, so that is my class. Now let's go ahead and do some of this outstanding check on learning. So which 2 answers refer to characteristics of the 802.11a wireless standard? Would it be A, it has a maximum data rate of 54 megabits per second? B, would it be 5 gigahertz frequency bands? C, would it be 2.4 gigahertz frequency bands? Or would it be D, it has a maximum data rate of 11 megabits per second? So which of these 2 answers are correct as it relates to the 802.11a wireless standard? And the correct answers would be it has a maximum data rate of 54 megabits per second, and it also operates on the 5 gigahertz frequency band. That is for the 802.11a wireless standard. Next question. Which of the following refers to a channel access method used in 2G GSM networks? Would it be A, CSMA-CA, B, TDMA, C, CSMA-CD, or D, CDMA? So which of the following refers to a channel access method used in 2G GSM networks? And the correct answer is TDMA, or time division multiple access. Now, for those of you listening to my voice right now, I highly encourage you all to get familiar with these acronyms, because when you go sit down to take your exams, they are going to be loaded up with acronyms, and they are going to expect you to understand what each acronym means as it directly relates to the question that they are asking you. Next question. What 2 are the frequency bands used by 802.11 networks? So which 2 answers are correct? Would it be 5 gigahertz, 5.4 gigahertz, 2 gigahertz, or 2.4 gigahertz? So which of these 2 answers is correct in reference to 802.11 networks? And the correct answer is, for 802.11 networks, they use 5 gigahertz and 2.4 gigahertz frequencies. That is the correct answer, ladies and gentlemen. All right, so in summary, we have talked about wireless technologies such as the 802.11 standards, cellular technologies, frequencies, channel bandwidth, channel bonding, MIMO, multi-user MIMO, unidirectional and omnidirectional antennas, and wireless site surveys. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.